Hello, it's Andrew from Real Speak here, and today, well, something different, slightly more of a long form video, something about how we actually learn languages and why learning languages physically changes your brain. So, I've been doing a lot of research on this, so let's go through this. One of the most remarkable characteristics of the human species is the phenomenon of speech. Owing to recent scientific advances, we are beginning to understand the mechanics of language processing, how it works. Although this science is new, it's in its infancy, and up until recently, scientists have relied on researching languages with stroke victims, or autopsies, or with people who had experienced some kind of brain trauma. Modern scanning methods like MRI, magnetic resonance imaging, are unveiling the mechanics of language and the brain. Some of the initial results are of benefit to language teachers and language learners alike. So, when you perform simple language processes such as reciting the months of the year in order, the motor and premotor areas for language are activated directly. But when you make a statement that requires a more extensive semantic and phonological analysis, other areas of the brain come into play or are used first. Put simply, this means that everyday tasks in language classes, such as reciting a list of vocabulary, can be performed without using parts of the brain connected to language comprehension and production. Therefore, by learning or by teaching pupils a string of vocabulary, we're not using our brains to process or produce the language, which means we're neither teaching you how to speak, or you're not learning how to speak, or how to understand the language. It's thought that vocabulary lists and drills are sent to what's called the paralimbic system, which works with our memory. However, in order to process and speak a language, two other parts of the left hemisphere must be activated and engaged in the process. Different areas of the temporal lobe, which is mostly on the left side of your brain, deal with different aspects of language. For instance, the Vernickis Area is one that allows you to understand words. The Broca area, on the other hand, is one that allows you to produce language or articulate words. So what's the Broca area? Well, Dr. Broca was a French scientist, a neurologist, and he studied people who had difficulties producing speech, something called aphasia. Dr. Broca had a patient who experienced severe problems in speech production and who could only say the word tan. When the patient died, Dr. Broca performed an autopsy and studied the brain very carefully. Dr. Broca observed that the area corresponding to the frontal lobe of the brain was severely damaged. This damaged area of the brain is just above the motor cortex behind your left eye, and it's responsible for controlling mouth functions. Therefore, Dr. Broca elaborated the hypothesis that this area must be the one responsible for speech production. Decades later, other scientists using brain scanning techniques proved that he was right. The second speech area to be covered is what we know today as Vernickis Area. It was discovered in 1874 by the neurologist Dr. Karl Wernicke. He was born in Tarnowice, Poland, but his family moved to Germany where he received his education and became a well-known scientist. Dr. Vernickis had a patient that spoke relatively well, but who was incapable of understanding the speech and discourse of other people. After the patient's death, Dr. Vernickis performed an autopsy of his brain and observed that there was serious damage in the area above the temporal lobe just next to the auditory complex. So he elaborated the hypothesis that this specific area must be responsible for speech comprehension. As with Dr. Broca, Dr. Vernickis' hypothesis was proven decades later. So the difference between these two areas is Vernickis is involved in the comprehension or understanding of written and spoken language, in contrast to the Broca area that's involved in the production of language. Scientists think that the areas of speech production and comprehension are the ones most strongly perceived in the brain due to the fact that speaking and understanding speech are skills that humans have mastered for longer than the other more recently developed skills of reading and writing. So as we know, we've been speaking and understanding speech for a lot longer than we have been reading and writing. Writing and reading are more recently developed. So what does this mean? How does this impact teachers and learners of languages? Well, when children learn more than one language, both Vernickis and Broca's areas are used. Well, with both or all of the languages. When people who have passed into adolescence or teenagers or are older learn another language, the Vernickis area retains the same function for the native and the additional language. However, the Broca's area actually seems to develop a specific sub-area for the additional language. So there's actually a physical change to your brain when you learn language as an older learner. So given that improving in any given task requires new neural networks, the sub-Broca area needs to become interconnected with the main Broca area and the rest of the neural networks responsible for language. The fact of the matter is, the comprehension part of the brain stays the same, or controls all languages, whilst the part responsible for production grows and develops. This may explain why it's easier to understand a language than it is to speak it. The comprehension is in one place, while the production part of the brain splits and grows a physically new part of the brain. So it really does seem that learners who are not children really need to practice their speaking. Learners who are children also learn better by speaking, as this is when they produce the language. The Broca area does not develop separate sub-areas for additional languages. The languages stay in the same place, making speaking multiple languages more natural and perhaps easier. This implies that the brain uses different strategies for learning languages, depending on age. A baby learns to talk using all the faculties: hearing, vision, touch, movement, which may feed into hardwired circuits like Broca's area. Once cells in this region become tuned to one or more languages, they become fixed. If two languages are acquired at this time, they become intermingled. But people who learn a second language at school have to acquire new skills for generating the complex speech sounds of the new tongue, which may explain why a second language is harder to learn. Broca's area is already dedicated to the native tongue, and so an ancillary or another Broca's region is created. So learning languages does physically change your brain. So we need to teach our Broca's area. We need to speak to grow the new Broca's area, but not with vocabulary drills or grammar charts We need to speak the language. We need to use sentences. The evidence is in our brains that learning languages physically changes our brains. And we have to use this process. Okay, so that's the end of this video. I hope you enjoyed it. Quite scientific, but if you did enjoy it, please give it a thumbs up. Please leave some comments in the section below. If you really enjoyed the video, well, please subscribe to the channel. And if you thought this video was great, well, you could buy me a coffee in the link below. And as always, if you want to have some English classes, or if you're a language teacher and you'd like some coaching, then please get in touch with me. The email is in the description below. So thank you very much, and I'll see you next time. Bye.